Welcome to Organic Chemistry. This short video is related to organic line drawing anatomy and coding and decoding these types of line drawings. Now, to understand what this drawing means, you want to remember a few things. First of all, carbon has a maximum of 4 bonds. Hydrogen atoms on carbon are assumed if other carbon atoms or other atoms in general are not present. A line will represent the type of bond that is depicting, that is a single line, single bond. Double or triple relate to double or triple bonds. Here I show carbon-carbon bonds of the 3 types, but that does not preclude us from drawing structures like this: CH single bond, CCl, carbon halogen bond, carbon oxygen bond would be a double bond like this, etc. Now, in the line drawings, we don't have time to draw out every single atom, and so we assign that any vertex will represent a C atom, carbon atom, and whatever is not connected to another carbon or other regular atom will be assigned as a proton, the H atom up here. Any terminus will be a methyl group. We'll use this drawing here and work backwards to indicate a number of these features. Also note, there are a few pitfalls that you want to be alert to and avoid as a savvy student. So first of all, the termini are represented as methyl groups, and in this drawing we have 2 termini here and here, and so those represent a methyl group at the end of our drawing. Now each vertex here is going to represent a carbon atom, and for instance on this point right here we'll have a carbon. It's attached to 2 other carbons by single bonds, and therefore to make up 4 bonds we are going to have to add 2 hydrogens. So we have these methylene groups at these vertices. Here we are also showing some double bonds and triple bonds. At this point in these double bonds, we want to remember that there's a hydrogen, and here there's also hydrogen. These are going to be CH methine groups. They're special because they're on a double bond. Right over here, we have another special CH group, methine. There's an H right there for CH. On the triple bond, pay close attention because what we have through the triple bond is a carbon here, a carbon here, a carbon here, and a carbon here. So we have 4 carbons in a row that are lined up because of the geometry of the triple bond. Continuing around, we come to this end, and again, to stay alert, we do have a carbon here. It's a CH2 group, and we're indicating that we have a CF single bond. We don't have another carbon sitting in here because this fluorine is taking up a position on the carbon that's right there. Over here, I will decode this a little bit. So we'll have a hybrid line drawing and formula. So this will be CH2, CH2, You can see how this task takes up a lot of time, and the reason why we use line drawings so it's more convenient to draw quickly. Let's say your backbone of something, you can add double bonds as needed. You can add other atoms as needed. And you want to grow the facility of being able to draw these quickly and also to understand what these mean, that is, decode those. So I call this coding and decoding organic line drawings. So the first task is to take a formula that's written in a rather specified way and turning it into a line drawing. And then contrary-wise, can you decode the line drawing to a formula? Let's go through these really quick. So I look at this. I have two methyl groups attached to a carbon and a hydrogen and a carbon next. So this will be something like this. The two methyl groups out here. This carbon is here. It has a hydrogen and is attached to another carbon. CH2 is up here. Come down, we have another methyl group and a CH. Actually, this would probably be written behind this one to indicate that we have a CH here, a CH3, and then the next one, CH2, will be this, and then we end with CH3. So this is decoding this. Now we can simplify it as a line drawing by eliminating the hydrogens and just showing vertices and lines. So here we have the dimethyl group at the end. We have this methylene, comes down, goes up, goes down. Now this methyl group, we have it drawn this way, but by convention we try to spread these out as much as possible. So this methyl group here, which I'll denote with a box, is this methyl group here. I'll draw a dot here to denote this methyl group right here, and so on. Let's do a decode here. So here we're interpreting that we have a carbon, and on it we have CH3 groups. This continues on, CH2, CH. We also have a methyl group down here, CH2, CH, and then methyl groups up here. Now this becomes tedious, but it's a good exercise. Again, we're learning the language and the arcane symbols of organic chemistry. We can wrap all this up into CH3 taken 3 times, attached to a carbon. This is attached to CH2. This is attached to CH with a methyl group added the correct way instead of up there. We continue on. We have CH2, CH, and then we end up with CH3 taken 2 times for this dimethyl group here. Let's move down here real quick. So we have a methyl group sitting out here, CH2, C. Now we have 2 methyl groups sitting on this carbon. So we'll put one up, one down. CH2, CH. And we have a dilemma here. This is CH, CH2. How can we resolve this having 4 bonds to it, but we don't have at the end a methyl group. That suggests, and it is true, that this will be a carbon-carbon double bond to get the whole complement of carbon bonds there. And we end up with this double bond at the end of this molecule, an alkene. Let's go ahead and simplify that. So I'm going to make a typical sawtooth pattern. I'm going to put both of my methyls down below and closer together to keep our main chain, that is our principal chain, going on the plane of the board. For instance, one of these methyl groups will be out and one would be back. So we come to here, and then we have a double bond at the end. Again, we aren't showing the hydrogen atoms in every case, but here we have CH2, CH, another CH2, a bare carbon here with carbons all attached around it. Finally, we have this example of decoding. Again, CH3 for the terminus, going to CH and a double bond, another CH up there, carbon. This methyl group is this methyl group. We have to complete 4 bonds to carbon here with the hydrogen. This goes up to CH2 and then ends with a terminal methyl group. In this case, the formula will look like this. Actually, you might see CH3 going this way, CH, CH, C, H, CH3. Again, this is that underline, is that underline. We continue and wrap this up. CH2, CH3. The way you'll get this is do the practice, keep the rules in mind, and look at it as a puzzle-solving activity. You will soon master the organic line drawings. Have a good day.